Welcome to the channel. In today's rapidly evolving world, technology is changing the way we live and work, and the engineering field is no exception. With AI, automation, and other cutting-edge technologies transforming industries, engineers need to stay ahead of the curve to remain relevant and successful. So, what are the key skills every engineer should have in the age of AI and automation? In this video, we'll break down 10 essential skills that will help you thrive in the future of engineering. Let's dive in. Number 1. Tech savviness. As technology advances, engineers need to keep pace with modern tools that simplify complex processes. Being tech savvy is no longer just a bonus, it's a necessity. Programming languages like Python and C++ have become essential across nearly all engineering fields. Python, for example, is favored for its versatility in data processing and machine learning, while C++ is often used for its speed and efficiency in systems that demand high performance. Having a foundation in these languages allows engineers to automate tasks, analyze data, and even control hardware. AI and automation are reshaping engineering projects. For example, civil engineers may use AI to model traffic patterns, while mechanical engineers can apply automation to optimize manufacturing processes. Understanding these tools enables engineers to boost efficiency and tackle problems on a larger scale. Data analysis platforms like MATLAB and R are critical for engineers who need to interpret complex datasets. MATLAB is often used for signal processing and simulations, while R is popular in statistical analysis. Both tools allow engineers to visualize trends, test designs, and draw insights that lead to better decision-making and project outcomes. Mastering these tools and languages helps engineers stay relevant and effective in a tech-driven world, laying a strong foundation for tackling modern challenges. Number 2. Problem solving and critical thinking. As automation takes on repetitive tasks, engineers are left with the challenge of solving complex, often unpredictable problems. This is where critical thinking and problem solving shine, skills that can't be fully replicated by machines. Analytical thinking enables engineers to break down large, complex issues into manageable parts. This skill is essential when troubleshooting, where finding the root cause is key. For example, in aerospace engineering, diagnosing issues in a spacecraft system requires analyzing data from multiple subsystems to find what went wrong. Some engineering problems require innovative, outside-the-box thinking that only humans can provide. For instance, designing structures that can withstand extreme weather requires engineers to consider not just materials and physics, but also unique environmental factors, an area where creativity and flexibility make all the difference. Approaches like design thinking and systems thinking help engineers tackle complex problems holistically. Design thinking focuses on human-centered solutions, while systems thinking considers how different parts of a system interact. Both approaches help engineers develop solutions that are both innovative and effective, leading to results that meet real-world needs. These skills, combined with the ability to analyze and adapt, are invaluable for engineers who want to make a meaningful impact in a world driven by rapid change. Number 3. Collaboration and communication skills. In today's interconnected world, engineers rarely work in isolation. With the rise of automation and AI, projects often require input from multidisciplinary teams, making collaboration and communication key skills for engineers. Effective communication ensures everyone on a project team, whether they're data scientists, designers, or marketers, understands the technical aspects without confusion. Engineers often translate complex ideas into straightforward language, ensuring each team member can make informed decisions. For instance, when explaining the technical aspects of a product designed to marketers, clear communication helps them highlight the product's unique features to potential customers. In a fast-paced, tech-driven workplace, engineers can boost teamwork by being proactive and adaptable. Engaging in collaborative problem-solving sessions, keeping open lines of communication, and sharing updates frequently fosters trust among team members. Tools like Slack, Trello, and project management software also play a big role, helping teams stay organized and transparent. Engineers often act as the bridge between technical development and broader project goals. They help non-technical team members understand how the technical elements align with overall project objectives. For example, in a product launch, engineers might explain to sales teams how a new feature works, allowing them to better convey its benefits to customers. These skills don't just enhance project outcomes, they make engineers valuable contributors to a team's overall success. In an increasingly collaborative field, strong communication and teamwork are what turn good ideas into successful, impactful projects. Number 4. Adaptability and continuous learning. With AI and automation evolving rapidly, the need for engineers to stay adaptable and continuously learn has never been greater. Those who stay current with new tools and technologies can better meet the demands of an ever-changing industry. Emerging tools like TensorFlow for AI development, ROS, Robot Operating System, for robotics, and IoT platforms such as Arduino or Raspberry Pi are reshaping the engineering landscape. Learning these tools allows engineers to integrate AI and automation into projects with ease, making systems smarter and more responsive to complex tasks. Certifications in areas like data science, cloud computing, or specific programming languages, like Python or C++, can give engineers a competitive edge. Professional development courses, such as those offered by IEE or Coursera, provide practical knowledge on advancements in automation, machine learning, and other cutting-edge fields. These certifications show employers that an engineer is committed to maintaining relevant skills. Numerous resources exist to support engineers in continuous learning. Online platforms like LinkedIn Learning, Udacity, and edX offer courses in specialized areas. Additionally, webinars, industry conferences, and engineering communities allow engineers to network and learn directly from experts. Adaptability and a commitment to learning are essential for engineers to remain relevant and capable of addressing tomorrow's challenges. By keeping up with industry advancements, engineers position themselves to lead and innovate in a dynamic, tech-forward world. Number 5. Data literacy and analysis. Data is now a cornerstone of engineering, especially with the rise of AI and automation. Engineers who are skilled in interpreting data can make better, more informed decisions, impacting everything from design to process optimization. The data journey begins with collection, often using sensors, databases, or manual input methods. Engineers then clean this data, removing errors or inconsistencies to ensure accuracy. Processing the data involves organizing and structuring it so it's ready for analysis. This stage is crucial, as poorly processed data can lead to misleading results, impacting project quality and outcomes. There are numerous tools engineers can use for data analysis. Excel remains a go-to for basic data manipulation, but more advanced analysis often requires SQL for database management, and Python for its powerful libraries like Pandas and NumPy. These tools enable engineers to analyze large datasets, uncover patterns, and automate calculations that save time and increase accuracy. In the automotive industry, data analysis helps optimize fuel efficiency by monitoring engine performance and driving conditions. In civil engineering, analyzing data from environmental sensors can lead to safer, more resilient infrastructure by predicting how materials respond to stress over time. Data-driven insights have even led to significant improvements in product design, like refining smartphone components based on user data to enhance battery life and performance. Mastering data literacy empowers engineers to harness the potential of AI and automation. By understanding and using data effectively, engineers can drive innovation, create efficient solutions, and make a lasting impact across industries. Number 6. Automation and robotics expertise. As automation and robotics reshape industries, engineers with expertise in these areas are at a significant advantage. Understanding and implementing automated systems is now a vital skill for driving efficiency, accuracy, and safety in engineering projects. Robotics plays a central role in many engineering fields, from manufacturing to healthcare. For example, in automotive manufacturing, robots are used for precision tasks like welding and assembling parts. In healthcare, robotics aids in surgeries and patient care, enhancing precision and reducing human error. This expansion of robotics allows engineers to design systems that perform tasks beyond human capabilities. Designing automated systems requires an understanding of both hardware and software. Engineers might program robots with languages like Python or C++ to execute tasks, or use specialized software like LabVIEW for control systems. Key steps include selecting appropriate sensors, actuators, and controllers, followed by creating an efficient workflow that integrates seamlessly with the surrounding environment. Programming these systems demands problem-solving skills to handle scenarios that require adjustments or troubleshooting. Automation has a profound impact on areas like manufacturing, logistics, and quality control. In manufacturing, automation streamlines production lines, reducing labor costs and increasing output. In logistics, automated systems in warehouses, such as robotic picking and sorting, optimize the supply chain by speeding up order fulfillment. Robotics also enhances quality control by allowing precise, consistent inspections, which catch flaws and improve product reliability. Engineers with automation and robotics expertise can create smarter, safer, and more productive work environments. As these technologies advance, engineers who can harness their potential will be well equipped to meet the demands of tomorrow's industries. Number 7. Cybersecurity awareness. With the integration of AI and IoT, engineering projects are increasingly exposed to cyber threats. Engineers need cybersecurity awareness to protect these connected systems from vulnerabilities and ensure their designs are secure. In today's interconnected world, everything from industrial machinery to personal devices can be vulnerable to cyber attacks. For example, a smart grid that controls power distribution across a city can be compromised if its cybersecurity isn't robust, potentially leading to widespread outages. Engineers play a critical role in securing these systems, making sure they function reliably without risking unauthorized access. Engineers can incorporate secure design practices like data encryption, which protects information in transit, and secure coding to minimize vulnerabilities within software. Using encryption, authentication, and secure protocols, engineers add layers of protection, preventing hackers from accessing or altering data. They might also conduct regular security assessments to identify and address potential weak points in a system. Engineers can strengthen cybersecurity by implementing fail-safes and monitoring systems that quickly respond to any unauthorized access. For instance, in autonomous vehicles, cybersecurity measures are crucial to prevent external control. Engineers ensure that these systems can detect anomalies, isolate compromised sections, and continue operating safely. Additionally, engineers can stay informed about the latest cyber threats, helping them design systems that adapt to emerging risks. By prioritizing cybersecurity, engineers not only protect their projects, but also contribute to a safer digital ecosystem. In a world of connected devices and automation, cybersecurity awareness is essential for building resilient, trusted systems. Number 8. Project management and leadership skills. As engineering projects grow more complex, the need for skilled project managers and leaders in the field becomes essential. While AI and automation can streamline certain tasks, human oversight is crucial for coordinating teams, managing timelines, and ensuring project success. In engineering, effective leadership goes beyond technical expertise. Leaders are needed to set goals, inspire teams, and make tough decisions, particularly when issues arise. For example, a project manager overseeing a renewable energy installation may need to coordinate between designers, construction teams, and regulatory bodies, ensuring everyone's efforts align with the project's goals. Strong leadership enables teams to navigate challenges and meet deadlines. Engineers can grow their project management skills through courses and certifications, such as Project Management Professional, PMP, or Lean Six Sigma, which focus on managing processes, reducing waste, and improving efficiency. Additionally, gaining experience in planning and coordinating tasks on smaller projects can help build confidence and skill in larger project management roles. Engineers can also work on soft skills like communication and decision-making, which are vital for effective leadership. Digital tools like Trello, Asana, and Microsoft Project have become valuable for tracking project timelines, assigning tasks, and monitoring progress. These platforms allow engineers to create visual project boards, prioritize tasks, and communicate updates with team members. They can also integrate with other tools for file sharing and version control, making it easier to coordinate complex workflows and ensure every team member has access to the latest project information. Project management and leadership skills empower engineers to take their projects from concept to completion effectively. By learning to guide teams and manage resources well, engineers can deliver successful outcomes and drive innovation in their fields. Number 9. Ethics and responsibility in engineering. As AI and automation become more embedded in daily life, engineers face the responsibility of considering the ethical implications of the systems they create. Balancing innovation with accountability is now an essential part of engineering. AI and automation introduce unique ethical challenges, particularly in areas like data privacy and algorithmic bias. For example, AI algorithms used in hiring processes or loan approvals can inadvertently reinforce existing biases if they rely on historical data that reflects unequal treatment. Data privacy is another critical area, as AI applications in healthcare and smart cities require personal data to function effectively, raising concerns about how this information is protected and used. Engineers play a key role in addressing these challenges by designing algorithms and systems that prioritize fairness, accuracy, and respect for user privacy. To innovate responsibly, engineers need to think about the social impacts of their designs, ensuring that technology benefits society as a whole. One way to approach this is by implementing ethical frameworks in the design and testing phases. For instance, engineers can use guidelines to assess a technology's impact on different populations, identify potential risks, and develop ways to mitigate those risks. Engineers can also work closely with ethicists, legal experts, and communities to understand and address any unintended consequences. There are several cases where ethical considerations have become central to engineering decisions. For instance, in autonomous vehicle design, engineers must program AI to make quick decisions in accident scenarios, raising questions about who or what gets prioritized for safety. Another example is in facial recognition technology, where misuse could lead to surveillance and privacy violations. Engineers developing these technologies must find ways to balance functionality with ethical considerations, protecting users' rights while advancing the technology. Ethics and responsibility are core to engineering in the age of AI. By approaching their work thoughtfully, engineers can create technologies that not only innovate, but also respect human rights, privacy, and fairness. Number 10. Creativity and innovation. While AI and automation are powerful tools, human creativity remains irreplaceable in engineering. Engineers need creativity to push boundaries, design novel systems, and solve complex problems that machines can't address alone. Creativity is essential in engineering because it allows engineers to approach problems from new perspectives. Rather than relying solely on existing solutions, creative engineers think outside the box to come up with unique ways to tackle challenges. For example, when designing a new product, creativity enables engineers to integrate innovative features that improve functionality or efficiency. In problem solving, creative engineers can find solutions to issues that may seem insurmountable at first, like optimizing a manufacturing process or designing energy-efficient infrastructure. One notable example is the design of the Burj Khalifa in Dubai, the tallest building in the world. Engineers face challenges in structural design due to extreme height, wind pressure, and seismic activity. Creativity was key in designing a strong yet flexible structure capable of withstanding these forces. Another example is the development of the Tesla electric car, where engineers pushed the boundaries of battery technology and automotive design to create a vehicle that was both environmentally friendly and high performance. These projects demonstrate how creative thinking drives innovation and leads to breakthrough advancements in engineering. To cultivate creativity, engineers can embrace an open mindset, explore diverse ideas, and collaborate with professionals from different fields. Participating in brainstorming sessions, attending workshops, and reading widely can also spark new ways of thinking. Engineers should learn to ask the right questions, experiment with unconventional solutions, and be open to learning from failure. Encouraging an environment that values creative input, where risk-taking is rewarded, can further enhance innovation within engineering teams. Creativity and innovation are vital in engineering, even in an age where automation and AI are becoming more prevalent. Engineers must continue to push the limits of what's possible, combining technical expertise with imaginative solutions to solve the world's most pressing problems. And there you go. Those are the 10 essential skills for engineers in the age of AI and automation. The future is full of opportunities, but it's up to us as engineers to keep evolving and mastering these new tools and skills. If you found this video helpful, make sure to like, comment, and subscribe for more insights into the world of engineering. What skills do you think are most important for the future? Let us know in the comments below. Thanks for watching, and we'll see you in the next video.